Hello friends, welcome back to my channel. This is Aaheli Bhattacharya, an 18-year-old pursuing B.Sc Statistics and Data Science. Today we are going to study one of the most interesting and important part of descriptive statistics, which is graphical representation of data. So graphs and charts make statistics more meaningful, right? Why? Because numbers alone can sometimes look boring or difficult to interpret. So let's dive in. First, we're going to start with the definition. So what is the definition of graphical representation? Graphical representation of data is a process of presenting data and information using visual elements such as charts, graphs, plots, and diagrams. In simple words, it means transforming raw data into visual format. That makes it easier to understand patterns, trends, comparisons, and outliers. Now, the next question comes in our mind is why we use graphical representation. Let's write the question. We use graphical representation mainly for actually three reasons. First is to summarize large amounts of data in a simple and clear way. Summarize large amounts of data in a simple and clear way. Next is to visualize trends, distributions, and relationships that are not so obvious in raw numbers. Okay, I'm just writing the keywords. Visualize trends, distributions, and relationships that are not so obvious in raw numbers. Third reason is to make complex data more accessible. And easier to understand even for people without a technical background. So basically, graphs help us to see the story behind the data. All right. Now coming to our next topic, common types of graphical representation. I'm just writing GR, okay? Common types of graphical representation. First, or not first, actually there are several types of graphical representations commonly used in statistics. The most important ones are, first is line diagram, then bar charts, histogram, pie chart, Ogive graph. This is actually new here, okay? Ogive graph, which is also known as cumulative frequency curve. All right, let's go through them one by one. For today, we're going to study only line diagram. Okay, so let's start with line diagram. A line diagram is the simplest way to represent data using points connected by straight lines. Okay, so what do we use? Use points which are connected by straight lines. On the x-axis, we usually take time, categories, or independent variables basically. Independent variables. On the y-axis, we take the values or frequencies of the data. So basically, dependent variables. When the points are plotted and joined, the line shows how data changes, for example, over time. So line diagrams are especially useful for showing trends, such as changes in temperature over a week or population growth over years. I actually took these two examples to explain the line diagram. So yes, let me tell you how to draw it. Let Let me take out the question. Yes, got it. Let's say question is, or the graph or the observations given are daily temperature over a week. What are the observation? Let's plot it. Not plot it, we'll plot it later. Write it, note it. Day and temperature. Could have written nicely. Yes. Day and temperature. Temperature is in degrees Celsius, okay? First is Monday, then Tuesday, Wednesday, Thursday, Friday. Can you fit it? Saturday? Yes, barely. Okay, anyway, Sunday. Now let's write the temperature. First is 30, 32, 34, 33, 31, 29, and 28. How will you start plotting the graph? Or maybe just keep the question here. Yeah. Will we use a scale? Yes. Maybe I can use a scale. Okay, enough. Yes. So this is the y-axis. This is the x-axis. Here, what will we plot? Days of the week. Okay. And here, we'll plot the temperature in degrees Celsius. From how we will start? We can start from 25 maybe. Let's say we say 25 and then next we say 27, 29, 31, 33, 35. That's enough because we have till 34. All right. So, and here we will plot Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and lastly Sunday. First is 30. Where is 30? Here almost. So we got 30, then 32. For Tuesday, you see 32 lies here. For Wednesday, 34, which will barely lie here. For Thursday, 33, which will lie almost here. For Friday, it is 31, so it will lie almost here. Saturday, 29, so it will lie here. Sunday is 28, so it will lie almost here, midterm. You will not plot like, you won't do all these things, okay? Like the dotted lines, you'll just plot like this. Here, join the dots. And your line diagram is ready. You won't do all these dotted lines. I did just explain, okay? Anyway, you understood. Now coming to the next question. Next is population growth. The observation given is population growth. The scale given is in thousands. Okay? So here and then population. Starting pop, okay? Let's say 2016, 17, 18, 19, and 20. Population is 250,000. The scale is in 1000. The values are 270, 290, 300, and 310. You can also give a kink here if you would like, because the values are different from 0 to 25, right? So yeah. Anyway, coming to the next question here. Now again the scale. Yes. Enough. This is the y-axis. This is the x-axis, as you already know. Now here, how will you plot it? Let's start from 250. 250, 260, 270, 280, 290, 300, 310, 320. Why did I take 320? Because it's always better to have a preceding, or I mean the succeeding value after the original or the last value. Okay. Now let's plot the x-axis. Just 2016, 17, 18, 19, and 20. Let's plot it. First is 250, right? Then is 270, then is 290, then 300, and then 310. All right. How will you plot it? Like this. Okay, done. So these were the two examples which I wanted to show if you had any doubt on graph. Okay. Now coming to the next part, which is the advantages. Advantages of graphical representation or the line diagram, anything. Let's say advantages of graphical representation. Or for now, just line diagram. First is, now what do we say about line diagram? Is it simple? Yes. Is it easy to interpret? Very easy. So yes, what will we write about it? Simple and easy to interpret. Simple and easy to interpret. Second is, summarizes data effectively. Summarizes data effectively. All right. Very useful for time series data, right? We're talking about line diagram. Very useful for time series data. And helps in predicting future trends. Helps in predicting future trends. Now there are also some limitations of line diagram. Let's talk about that too. First is not suitable for categorical data. Basically, for the advantages, we can say that graphs are like shortcut to understanding the data. And for limitations, like they also have some limitation. For not suitable for categorical data, we can say, what is categorical data? Can you say? It is qualitative data. Qualitative data or abstract data. So, this is the limitation. There are also, I think, 2, 3 more limitation. Let's say, it can be misleading. It can be misleading. If the scale is not mentioned or not uniformed, uninformed. If the scale is not mentioned. Right? Third or the last limitation will be too many lines may clutter the graph, which is difficult for understanding. Too many lines may clutter the graph. Which will be difficult to understand. Right? For the scale, we already mentioned here the scale, right? Like it is in thousands. And in the first part, we said that it is in temperature. The temperature is in Celsius. So these are to be mentioned. And yes, that's all for today's session on graphical representation of data. We covered the definition, why we use graphs, the main types, and then discussed the line diagram in detail along with the advantages and limitations. Yes, so for the next video, we will discuss about the bar diagram. If you found this video helpful, don't forget to like, share, and subscribe to my channel for more statistics content. Thank you for watching, and yeah, I'll see you in the next class. So yes, and different color. Bye. Take care. Keep studying.